Hello, everybody. Today, we are going to learn how to model a pair of working helical gears. And hopefully, if you have access to a 3D printer, you should be able to print them and see how they work in action. Let me share my screen. All right. So as I said, our goal here is to model a pair of helical gears, as you see, and make sure that they are matched and working with no issues. So we're going to model 3 components, the 2 gears and 1 base. I'm going to show you the top view. As you see, one of them is a right hand and another one is a left hand, and they are working nicely together. Let's get started. Going to open a new file. So first, under Utilities, select Add-in and then select Fusion App Store. In Fusion App Store, search here for helical gear. You should be able to see different options. Some of them you have to pay money, some are free. Go with the free one. I like the first one, the simple one, Helical Gear Generator. So click on that one, then select your system. I'm here with Windows 64, and then click Download. So after you download it, you install this little add-in. Just keep in mind, you need to first close your Fusion 360, then install this add-in, and after that, you restart your Fusion 360. All right? Otherwise, it would crash, and you don't want that. If you do it correctly, under Solid, then when you click on Create, you should be able to see Helical Gear appear there. You click on Helical Gear, now this window's popped up, and under here we can actually decide the helical gear system that we want. So it can be a normal, radial, or Sunderland system. You can read about each, but we'll go with the standard one, which is a radial system. Next, you need to decide if your helical gear is a right hand or left hand. Shortly, I'll explain that. Let's go for now for right. We have the helix angle, which is for each helical gear, we have that angle, the pressure angle. The helix angle can be any number between 10 to 45 degrees, depends on your design. Let's go with 30. And pressure angle, again, 14 degree to 25, but let's go with 20 degree. Module, as we define it, is the ratio of diameter of a gear with the number of teeth. Let's go with 3 and 16, the number of teeth. We keep the backlash as 0, and the thickness of the gear is 10. Now, if I click OK, this is the gear that I have. This gear, keep in mind, it has 16 number of teeth. And if I attempt to draw the pitch circle for this gear, the pitch circle is the diameter of pitch circle is, remember, the number of teeth, which was 16, multiplied by the number of the number of teeth multiplied by the modules, which gives me 48. Our number of teeth was 16, and the module was 3. Now that we are here, why not we make also a hole there with diameter of 10. Just gonna make this diameter 10 perhaps, and stop there. Next, we'll create our second gear. So for the second gear, everything must be the same except the right hand. Now it must be left. The previous one was right. Now this must be left. We keep the helical angle and pressure angle exactly the same. Module must be the same. Number of teeth is up to you. If you want a larger gear, we go with the larger number of teeth. Let's go with 40. And the thickness obviously is the same. If I click OK, the second gear appeared there. Now, I can do the same. I can actually draw the pitch circle for this one. Keep in mind, 40 teeth multiplied by 3 gives me the diameter of 120. And also I can try to perhaps do the diameters here of 10. And repeat the same process to cut like a bearing position there. These two gears are matched on top of each other. I can simply click on one and move it. So I can move it to the left or right, but how much should we move it? Obviously, the amount that we need to move it is the distance between center to center, which is going to be the half of diameter of the first one plus half of the diameter of the second one. It's going to give me 84. I'm going to quickly stop sharing my screen, and what we'll do just as a practice, how we manage to find the distance between center to center. So let's say this is my first gear pitch circle. And let's say that this is my second gear pitch circle. All right. So the first gear, this distance, let's call it D1. D1 simply is M multiplied by N1. Our module was 3 and N1, 16. So it gives me 48 millimeters. The second gear, the diameter of the second gear, let's call it D2, simply is M multiplied by N2, 3 multiplied by 40, which gives me 120 millimeters. Therefore, the distance between center to center, obviously, let's call this one L, is 48 plus 120 divided by 2, which gives me 84. Let's go back to our model. I'm going to share my screen again. All right. So this is how we figure then the center between these two. Now let's make a new component to mount these two gears on that. So I select, and it asks me because we move it, capture position. I'll draw a circle with diameter of 10 here. And just to make sure that I select the other center correctly, I know now the distance here has to be 84. So I'll go with 84. And I draw another circle with diameter of 10. Stop that. Now I can extrude these two. Let's do that. I select two sides, and one side will go 10, and other side 20, but you can have your own number, doesn't matter. I just draw two simple cylinders or two pins that these two gears can sit on that. Let's have a base for them. And again, you can design it in different way. This is how I do it, but you can obviously have your own way of making the base and make any changes that you wish. And if I stop there, now let's just simply extrude at by maybe 5. We don't want that to be too thick. Oh, I should have selected the other side. Let's extrude it again. And 5. All right. So we have the base there now. All right. Now we want to have some animation, making sure these two gears working with no problem. So first of all, we need to do something else. These two gears, we want them to sit on a base there, right? Not touching this platform there. Let me just hide them for a second. Okay. Why not I just put my surface there. I draw another circle, this time radius 15, and another one there with radius 15. Stop there and extrude this portion. And let's do that portion by 10. Right. As I said, you may do this differently depending on the design you want to do. Now, for each of these gears that we have, we know they are going to sit on that bearing there, right? Both of them. Okay. Next step. So right now, these three models, they are ready for 3D print, but it's good to have them in the model to see how they work. Sort of adding an animation there. So this base, my component 3, right? We can even rename it. So we know which one is, let's call it base. I just right click on it and I select ground. It means I want this base to be fixed. And I want these two gears to rotate about this base. That is very simple, that part. You go to assembly and select joint. For the joint, you go to motion and select revolute. Now, you select the first one and simply select center there. Let me just repeat it again. So I'll go to assembly, joint, and simply I select that part and that part. So remember, I selected something to make sure that these two work perfectly. Now I can rotate that one about that. I'll repeat the same process for the second one. I'll go to assembly, joint, and I select that base, and I select the other cylinder. This is again a revolute joint, and I click OK. So this one also, it works. But as we see, these two working independently, we want to link them, right? So what I will do, I move one of them so they be as close as possible between the teeth. It doesn't matter how accurate it is, but something that approximately is right there. Now I want to link these two motions together. Under assembly, I select motion link and I select capture position, right? So I select my first link and I select my second link. Okay, what does it say? And their motion is not synced together. Okay, so I stop animation here. So I know that if my first joint rotate 360 degrees, the other one is not gonna rotate exactly 360 degrees. So the ratio of their speed is simply the inverse ratio of the number of teeth, 40 divided by 16. So I'm going to repeat it again. The first joint, which was this larger one, larger gear, if it rotates 360 degrees, the second one is going to rotate 360 degrees multiplied by this number. This number is the inverse ratio of the number of teeth. All right. So if I play animation, still we see they are not working the way that we want. And most likely, you can guess what is wrong. So let me stop animation. You can stop the video and think about it. But the answer simply is, if one of them is rotating clockwise, the other one must rotate counterclockwise. So I put a negative sign there. Now, if I click, you see these two are working nicely together with no problem. All right. So we made our two gears. You can test it to make sure that they work with no problem before 3D printing. If I rotate one of them, you see the other one is rotating with no problem at all. And now you know the ratio of speed of these two. Of course, the smaller gear will rotate faster because we know for each complete rotation of this larger one, the smaller one is going to rotate 40 divided by 16, the inverse ratio of number of teeth, all right? So before you 3D print them, you can 3D print them as a simple model like that, or you can be a little bit creative. For example, you may decide to, let's select this, maybe a smaller gear there. And let's perhaps capture position. Under here, text, maybe you can add a text here. Why not? If we can 3D print that, why not we take advantage of the freedom that additive manufacturing or 3D printing gives us, right? So let's just make it 8, smaller a little bit. Okay. I just right here, UBC, the University of British Columbia, and stop there. I can click here, select that, and perhaps extrude it by 5 millimeters. Maybe I'll do the same. Select the other gear. Maybe on the other gear, we write something else, whatever we wish. Let's go here, for example, I write down Manu 265, which is the name of the course code at UBC, Manufacturing 265, which is a cool course here at UBC. And we extrude that one. And we can add the thickness 5 or whatever we wish to do. All right, so we have now our gears ready. They are working nicely together. We can even be a little bit creative, change the appearance of each of them. Why not? We make this blue, we make that one red, and maybe we give a brass color to the base. Close. All right. So our model is ready. For 3D printing, we have to make STL of each component separately. Simply, I'll go to this part, file there, and I select 3D print. Let's start with the large component. I select the large component. So my units is millimeter. I want STL file, and I just click the refinement high, and I click OK. And I call this one year 1. Save. All right. So I'll repeat the same for the second one, 3D print. Second one, OK. And call this one gear 2. And then we'll do the same 3D print the base this time. And I select OK. Base. So I managed to find, to calculate the three STL file for the gear 1, gear 2, and base, and they are ready for the slicing and 3D printing. Hopefully you have access to a 3D printer and you can make it. And remember, this one was the helical gear generator that initially we downloaded and we installed it. All right, hopefully you learn how to model a very simple pair of helical gears working nicely together, and you could have some fun writing things on them like the way that I did, and perhaps you can assemble them and make sure that they are working nicely together. Also, I suggest, since with 3D printing, with the machine you use, it has perhaps some tolerance. Always I suggest, maybe in your model, make the diameter of each of these cylinder, instead of 10 millimeters, why not make them, let's say 9.5 millimeters? This is just for tolerance, right? Then easily, you know, this one can go and sit there, right? And the same, the diameter of the other one, 9.5 millimeters. And another things that I advise, the center to center of these two, I suggest, based on the calculation that we did for the example that we did was 84, but if I want to 3D print it, I make this center to center, perhaps maybe 85 millimeters. This is just for the tolerance, making sure that these two gears working smoothly together. And like always, maybe you need to do some trial and error, which is the nature of learning. Good luck, and I hope you have some fun with this project.